Is it working?
Yes, ma'am. Live हो गया है, ठीक है.
Okay, take it. Thank you. Okay, so welcome to Testbook SuperCoaching, right? For CSIR UGC NET GRF. Now, today we're working up with the understanding of how we're going to work in the clarity of going with the mathematical sciences portion, right? So in the mathematical sciences we have a lot of topics, a lot of subjects to be very very important working for CSIR, right? As we have the first one to be real analysis, second is to be linear algebra. Accordingly we're going to move over here, right, in our YouTube live classes as well as in our master classes. So you have to be very much attentive by coming up over here, right, in the sessions and working out with me. Okay, so let's proceed further and let's start with this today's topic, right? And before moving right away, moving up before to today's topic, let me just introduce myself to you all, right? So this is an outlook to my profile. Another information for all of you is that that I am giving you a discount of 25% if you join the master classes, right? And we have these are basically free of cost classes, but we are going to give you, if you come up over there and get the paid subscription, right, you're going to get the 25% discount. You just need to use the code DOLLY Dolly, right? And another thing we're going to work up over here is the classes are going to be on the two timings, right? So the one is going to be YouTube live classes, that's 2 p.m. to 3 p.m., right? And another one is going to be on the textbook app, right? So you're going to work up over there, right? For 30-35 minutes we are going to have a class and we're going to understand the different workings of how to proceed in our further sessions, right? Okay, so this is an outlook to my profile on the left, which you can see. You can also join my Telegram group. The link is given over there on the top, right? For getting the better understanding of the classes and for getting the links, right? So if I proceed further, right, you can see the outlook to my profile. I'm a qualified GRF in ex-faculty at An Academy and ex-faculty at DIPS Academy. I have a specialization for the IB boards, right? I've taught a lot of several institutes and online platforms and independent research in the field of statistical analysis. Completed my Masters of Science in Mathematics and Computing and my Bachelors of Science in Mathematics honors, right? And guided a lot of students up till now for different and variation of the competitive exams. Moving further, let's move further and understand about for the real analysis portion, right? So in a way we are going to understand today about the real analysis and working out with the questions relatable to real analysis, right? So in the marks distribution we have 50 to 55 marks for our real analysis portion. The first topic to pursue over here is basically depending upon your points of topology, countability and uncountability, right? And we are going to go into details to understand what all topics we are covering over here in each and every main topic, right? So the subtopics are very very important as per the point of view, right? And then I'm going to put up certain questions relatable to this so that this helps you out to work up even more better for this. Okay. Okay, so we're working up with the real analysis practice questions, right, for the previous year, right? And this is the important highlights of the super series which we have, right? We're going to understand the exam pattern over here. We're going to do the subject wise, right? And we're going to do the building blocks of the subject topic wise and the top important topics. And moving further, we were talking about the real analysis portion where we are going to go in the understanding of this 50 to 55 marks, right? And this is actually giving you a clarity, right, to work with the understanding of the topics such as points in topology, countability and uncountability, sequences and series, right, limit continuity and differentiability, uniform continuity and uniform convergence. We're going to go with the understanding of Riemann integrals, right, metric spaces, different types of functions, right? One by one we're going to pick up the topic, we're going to work with the questions of that, and then we're going to understand how these questions are working out further. Okay, so let's proceed up to work. Okay, here is your first question, everyone. Let's look at it. It says, let f be the set of all functions working from close 01 to close 01 itself, right? If you want to find out the cardinality of f, right, working up as small f, then you need to check that which of the followings are going to be correct, right? So this is saying that f is going to be similar to close 01, f is less than the cardinality of 01. F is greater than C, where cardinality of 01 is C, right? F is countable, right? So these are the four options we are giving up to us, right? So try and work out with this question. I'm giving you 2 to 5 minutes, right, to work out with this. And if you have any doubts relatable to the question, please ask up in the chat section. Otherwise, I'll explain you how to do the question further, right? Functions working from 01 to 01 is going to give me a cardinality, right? With the help of the transfinite numbers, I'm going to go. So the set of all functions working from the closed interval to closed interval is continuum to the power continuum, because the cardinality of 01 is continuum and the cardinality of 01 is again continuum. So this takes to the cardinality of 01 raised to the power of the cardinality of 01, which is continuum to the power continuum, which is always and always greater than the continuum, isn't it? Right? So from that particularity, we can see that cardinality of which f, capital F, which is coming out to be small f, that's going to be equivalent to something which is bigger and more bigger than your capital, which is bigger and bigger than your continuum, that's C, right? So out of that, f is similar to the interval 01. That's not possible at all. So A option is discarded out from there. For the B option, it says f is less than the cardinality of 01. Not possible, because it's coming out to be continuum to the power of continuum, right? That cannot be less than continuum anyhow. It will always and always be greatest. The option C is correct in that case, right? It cannot be countable, because continuum comes up for the uncountable number of sets, right? So that's the cardinality in the transfinite numbers, so it cannot be countable in that case. So option C is the only option which is correct for this question. This is the first question, which is a part of your previous year questions for the real analysis. Hope you understand it quickly and a real much better, right? So let's proceed to the next question then. So this is your next question, everyone. Try and some subset in B which is going to be countable as A is given to be countable, right? Whole of the B cannot be countable in a way. Since it's a 1-1 map, it's not onto. If it's onto, that means if it tries to be bijective. In the case of bijectivity, I can talk about the countability of B, right? Whereas uncountability doesn't comes up in picture, right? Only and only the option can be possible is that when you found out a subset of B, right, which is coming out to be countable, because if A is countable, then n number of sets can be n number of elements can be possibly to be mapped in B, right? And since B is A to B is 1-1, right? So those B are going to be existing up, right? So the cardinality in some subset of B, which I'm going to create, which is coming out to be f of A, right, which are the images of A in B, that set is definitely going to be a countable set for me. Clear? Is it clear with everyone? Right? Is there any doubts anybody is having? You can ask them in the chat box. Okay, let's proceed further with the next question. Here is your next question. Please start working out with this, everyone. Okay, so is the third question, right? Let's proceed with this. It says, let A be an infinite set of disjoint open subintervals of O1, right, and open O1. Let B be the power set of A, right? Then we have to find that which of the things are possible. Either the cardinality of both the sets are coming out to be equal. A set is coming out to be similar to 0-1, either A or B. That's in B and C option. And the third one is that the both are coming out to be uncountable. So please try and work out with this question, and then we'll discuss up. I'm giving you 2 to 5 minutes to work out with the question, and then we're going to discuss how to do this question. Okay, these are like very simple questions. You don't even require to use your pen and paper. It's just your understanding, right, which is going to help you out to work with these kind of questions, which is basically the first and foremost part relatable to countability and uncountability, considering up the cardinality of sets in picture. Okay, go ahead, please, everyone. Try and work out with this question. Okay, so the only option which over here is turning out to be incorrect is the option D, because even if your A turns out to be countable, your A is, B is countable, your A is not countable. For sure A is not countable, but how can B be countable in that case? Because both are infinite sets and they are only considering those kind of pre-images, and this can only be possible if the map is turning out to be onto, right? So this cannot be possible. Both the sets have to be similar in that case, and one is coming out to be countable, then the pre-image set is also going out to be countable for that case. So option D is coming out to be incorrect for me. Okay, so I just want to say one thing, that we're going to proceed further questions also. This is what I feel which are basic building blocks of your real analysis, which we are going to work with the practice sessions, right? So this was the first practice session relatable to countability. In the next session of countability practice session, we're going to work more advanced questions, right? And then we'll be proceeding over the points of typology, the further things, right? Want to say one more thing about it, that don't forget to subscribe up our Testbook channel and on the Telegram, as well as connected us on with the YouTube, right? Don't forget to press the bell icon so that you can start getting up the notifications for my new videos, and you can join and further work out with the mathematical sciences portion in a very easier manner. Okay, everyone? Okay, let's come back to the questions which we were proceeding up. Here is the next question. Please start working over the next question. Question number 5. It says if your f is a function working over the domain A and the range B, right? You have to check which of the following are turning out to be correct. Okay? So if your B set is countable, will the A is countable in that case? For sure, your image set cannot be uncountable if your A set is turning out to be countable in that case. So first implication is true. What about the second implication? That if your A set is countable, B has to be countable in that case. No, the B set can be uncountable, so the B option is incorrect. But the C option is correct, right? Whereas you have A to be uncountable, implying to be B uncountable, because if the one set is uncountable, the domain function relating up to that set, taking up all the images in the range set, that's going to be uncountable in nature. Is it clear? So all the options will going to be correct in this case. Answer is yes, that's correct. Very good. Want to take time to look up to the question again and just want to ask anything, you can just go ahead. Okay, I think so that's enough, right? For today, we're going to meet up then in the next